Okay, so good evening, everyone. Welcome to the 10th live session for the course Basic Environmental Engineering, Pollution and Abatement. Uh, yeah, so let me share my screen. Okay, so far we have been discussing on various, you know, uh, pollution treatment strategies. So, till now we have discussed how pollution is generated from various from industries. What could be the type of pollution from in case of air pollution, water pollution, and sludge management. So in the last week, we have been discussing on what, uh, depending on particular industry, what could be the uh, particular pollutant, because depending on the type of instrument industry, the pollution, the contaminants in the stream, may it be air pollution or the emission in the air or water pollution. So all such sort of pollution might be different and the composition might be different. So we had started with looking into the specific industries which generates good amount of pollution. So how do they take care of pollution? So now we will be discussing on another important industry, which is ethanol production. Okay, so this is a very basic. You would have seen this reaction in your schools also, where you would have seen the fermentation of sucrose. It gives you glucose and fructose, which further, uh, sorry, the sucrose gives you glucose and fructose, which further gives you, on fermentation, it will give you ethanol, right? So, it is a big industry where the agro products, which include sugarcane, molasses, coarse grain, these all raw materials, they they are used to because here the main component of these agro products, it is nothing but sucrose. So here we will be utilizing these raw materials and converting the sucrose which is present into these raw materials to form ethanol as the product. So if we look into the process flow diagram, majorly if we talk about Indian market or Indian scenario, then the ethanol production is performed by using molasses. Okay, this molasses is obtained as the byproduct. Okay, so it is a byproduct from sugar industry, right? And it has around 40 to 45% still sugar content which is left in it. And that sugar is nothing but sucrose. So now this molasses, we use it, and what we need to do, we need to convert it into it, firstly this and secondly this by using fermentation. Okay, so here fermentation is usually carried out by adding yeast to it, which is the fungus. Okay, so this is a microorganism which acts upon the molecules to form uh, the final product, which is ethanol. Now, any fungus, if it undergoes any reaction to convert one reactant into product, so in the absence of air, so it is reaction is known as fermentation reaction. right? So this happens in the absence of oxygen. So what is happening here? First, we take molasses and we dilute it. So now the yeast that we use, so for microorganisms, if we want to use them, we need to have a sterilized atmosphere so that there is no uh, contamination of these uh, or there is no impact of other environmental conditions on the efficacy of these microorganisms. So here we are using yeast. So we will allow it to grow, and once it has grown, it is added for the fermentation in a tank. Okay, so fermentation occurs. Now after that, uh, so it is washing is given, and the yeast is separated. Further, the decantation is given so that any solid material which is present, because there was molasses which was used. So, by providing decantation, solid is separated, and here sugarcane or sugarcane which was converted to molasses, it is a natural product. So, it is biodegradable in nature. So, it can be further used. The sludge which is obtained, it can be used as a manure or biomanure. So, that is the byproduct which is used for composting, right? So this byproduct is used for composting. Now, whatever the supernatant which is obtained after decantation, it is containing majority or it is containing our main product, which is ethanol. So here the top product, okay. So top product is nothing but ethanol. Okay, so it will not be only ethanol, but uh, the top topmost layer of the ethanol of the decanter contains our main product, ethanol. So now there are chances that we have diluted molasses. Okay, so there will be water content in the in this top product, right? So it will be water plus ethanol, and I don't know. Okay, so this will be water plus ethanol because we have even provided a wash. Okay, so now it goes to various columns. So these columns are nothing but distillation columns. Okay, so distillation, what happens is we try to remove um, or we try to separate two liquid components into uh, just a second. Can you see my slides? Just give me a moment. Okay. Yes. So, we were talking that here what we will have ethanol plus water. So now these are the two major components after decantation or the top layer of decantation. Now this, if we want to separate, then we will utilize distillation where uh, this ethanol having and water having different boiling points. So depending on the difference in the boiling point, they will the one which is having lower boiling point, it will be obtained at the top, and the one which is having higher boiling point, it will be obtained at a low at the bottom. Okay, so there will be a column ethanol plus water, and ethanol we will have at the top and water at the bottom. So this is a distillation column. So rectification column we provide, and here again there are different type of spent wash which contains the some side product or the byproducts plus ethanol that will be obtained, and these rectification column, because this water will not be pure, okay, so it will further have ethanol. Why? Because if we look into the boiling points, then there is a point. These type of mixtures are called azeotropic mixture, where after a certain point, these material they are not able to separate because they have constant boiling point. So these azeotropes are nothing but constant boiling mixtures, and since we are using here the boiling points, the difference in the boiling points as the mean to separate. Now, when its boiling point is same, we will not be able to separate it further. So, from the rectification column, we will have 95% ethanol as the product. Now, still there are 5% of uh, water content present in it. So now to remove that water content, what we will do, these azeotropes are removed through azeotropic distillation or some molecular sieve to further remove or for dehydration to remove the residual water content, which will give you absolute alcohol, which is 99.9% pure, and that is stored. Now, in all the steps, there are water which is separated and it is obtained. Okay, if you talk about this rectification column, there will be water plus ethanol mixture, and further there will be byproducts formed. So all those further there will be washing of equipments for, and if you talk about molasses, then even you have diluted it, and from the fermentation also. So all such sort of uh, uh, equipments and all such sort of steps, they generate wastewater streams and sludge, right? So sludge that is formed is mainly obtained after decantation, which is used for biodigestion and digestion, and obviously used for biocomposting. And another way you can use it is it has high calorific value, so you can send it to boiler. Okay, so this is how you manage the sludge that is formed in the uh, ethanol production industry. Now, next is if you talk about water purification, then the water purification for that, whatever the wastewater is generated, either we can directly send it for evaporation and send it to incineration, because majorly you will see there are biodegradable components organics present in it, right? So because, and here we have provided decantation, which means that solid content will be very less. So we can provide evaporation and lastly incineration so that we can remove the biodegradable organics, right? Now, if we talk about another method which we can use is due to the high content of organics, we can send it to biomethanation so that we can generate biogas. Okay. And also, the aerobic processes are not advisable if we have high contents of organics. So, first step will be biomethanation or biogas plant. Secondly, we can either send it to evaporation or we can send it for aerobic treatment. And lastly, whatever the water is obtained, there are very less harmful chemicals, so we can send it for irrigation. Or if we want to discharge it, Then we can provide tertiary treatment and in the form of UV treatment or chlorination and so on. Uh, because there is fungi also used, which might require disinfection, and it can be discharged into surface water bodies, right? So, uh, yeah, that was all about the wastewater treatment. And there is one more unit which is specific, which is CPU, which is condensate processing unit. So in that case, whatever the multiple effect evaporator condensate is you are getting. So multiple effect evaporators are nothing but they are used to concentrate any stream. So whatever the condensate you are getting, that also might be contaminated because it might be mixed, right? So it is first sent to equalization tank and conditioning tank. Later aeration and other uh, membrane processes, activated carbon filters, and so on, they are provided so that you can have um, clean, purified water. Now, if we talk about air pollution from this industry, then air pollution can be from the evaporators, right? Because vapor might evaporate, and it can, along with vapor, there could be some contamination also there, right? And noise pollution because of steam vents, leaks, and power generators. So all the instruments that are used in any industry it generates a large amount of noise, right? So, is there any doubt so far? This is about uh, yeah. So this was about the ethanol industry or distillery. Next is tannery industry. Now, tannery industry is nothing but the name is based on a earlier scheme where tanning process was provided uh, to the skin and hides of animals to produce leather. Now, instead of that tanning process, uh, we are providing chromium tanning. Okay, so earlier some different technique were provided so that leather can be produced, but nowadays chemical based tannery process is used where chromium is added. Okay, so let's see the process. So first process is nothing but uh, we collect the skins and hide of the animals, and first is we soak it in water so that we can able to remove all sorts of impurities which are present onto it. Now, then we provide liming where lime is added. Now here it removes the flash. Okay. Further, it can remove hair and other impurities which are present on also the skin, and other impurities which are present on the skin and hide of the animals, right? So now this liming process it alters the pH, and also it alters the uh, it removes the protein content, it removes all sort of unrequired material which right present in the skins and hides of the animal. Now, again, if there is any flash remaining, we remove it. These processes can be performed manually, or there could be some automatic processes which might be adopted for all these processes, right? And as I mentioned, that liming process it alters the pH. So in
Hello,
that
ma'am.
case, yeah.
Ma'am, I'm not able to see the your presentation. Has I mean the presentation closed?
Okay, just a second. I guess there was some issue in the connection. I will reshare this. Sorry for that.
Okay.
Yeah, so what we are doing here after the liming process, the pH.
Yes, ma'am. Now it's visible.
Okay, okay, thank you. So pH is altered and which might not produce required properties in the leather. So what we do, we remove the excess of lime by adding ammonium sulfate or ammonium chloride, right? And so this process, it will further help in maintaining the properties of leather. Now next process is the main process where chromium salts um, in the form of Cr3. Now chromium has two valencies and here we are using chromium 3. Okay, so for the tanning process where hides of the animals they are converted into the leather final product. Now this leather might not be the end product because it might require further processing in the terms of properties of it, because if you want to apply this leather for, let's say, for applying for um, you know the build of watches, or you want to if you want to produce leather jackets, so in that, depending on the type of application, whatever the leather is generated, it might not be suitable for the properties. So for example, you might need to enhance its physical properties like the strength of leather, also its visual appearance you need to modify, right? So in that case, you provide final processing steps, including dyeing of leather, where you provide the particular, depending on application, the color which is required for the leather. Then fat liquoring, or that is nothing but treating with oil water emulsion. Okay, so treating the leather with oil water emulsion, it improves the tensile strength of leather, because otherwise, if the leather is not processed, it will turn brittle on drying, which is not a property which might be required for any application. So what we do, we provide oil water emulsion, and final finishing is provided so that there is a shine on the leather and matte finish leather, depending on whatever the type of application you have, it is generated. Now if we talk about water pollution, then all these steps in this industry, they are highly dependent on the consumption of water. And further, if you see, then you see soaking, liming, flashing, deliming, or tanning process, dyeing, fat liquoring. All these processes, they are heavily water dependent, and each of these processes, they generate water, wastewater, right? Now, if we talk about the characteristics of water, then all the processes except tanning process. Now, these tanning process, it is rich in chromium. Okay, so Cr is a major component in like, which is a heavy metal, and it has some different properties. While if we talk about other methods, uh, other processes, then it will be not on, along with some Cr percentage, it will have high COD, BOD, uh, suspended solids, dissolved solids, and so on. So it is better to not so here the important phenomena which we had learned previously, to not club the pollution, which is by segregating the waste. Okay, so here we will not allow the stream from tanning process and all the other process to mix, so that chromium is not mixed with any other stream which is negligible, which is having no pollution or negligible pollution of chromium. So here we will be having two streams, one which is chromium rich stream and another which is non-chrome stream. So if we talk about chromium stream, then what it is done to recover chromium or to reduce the pollution, because chromium is a heavy metal which is highly toxic in nature. So, by recovering the chromium, what we will be able to do, we will be able to reduce its pollution and we will be able to reduce the consumption so that it has negligible adverse impacts. So, for recovering that, what we use, yeah, here it is shown. So, from MgO is added, yeah, so MgO is added,
Hello, ma'am.
yeah, hello.
Uh,
Your
sorry.
voice
I think
is
my internet is suddenly screen went out.
totally
Sorry,
breaking.
I think my screen was
Bhavya, your voice is totally not coming to me. Mm, if you have doubt, can you write it in chat box? Or if you are saying something, please write in chat. Okay, so let me just continue. Okay, so here what we are following is we will be segregating two streams. One is chromium rich stream from tannery process. Another is the wastewater generated from all the streams which might have negligible or very less quantity of chromium in it. So if we talk about chromium containing wastewater, so from tanning plant, whatever the chromium bearing wastewater, it is collected and you provide and send it to equalization tank so that the properties are uniformly maintained. Now you send it to MgO treatment where the pH maintained is highly basic, right? So in that pH range, what you are doing, you are converting chromium 3 into its hydroxide. Okay, now these hydroxides are precipitated. Okay, so these are solid in nature. So precipitated, right? So precipitates of chromium hydroxide are formed, and whatever the supernatant. Now, since there are precipitates formed, so you can allow the precipitate to settle, and there will be a top layer of water and there will be a bottom layer of precipitates. Now, these precipitates are toxic containing chromium. So, further to recover or reuse those chromium precipitates, you can treat it with sulfuric acid, and where you take the pH around 2 to form chromium sulfate, and that recovered chromium, which is chromium sulfate in the form of chromium sulfate, uh, you recycle it back to the process and it can be reused, but still depending on the efficiency of the process, not there are high chances that not 100% recovery of chromium is obtained. So in that case there are little bit traces of chromium might be there, but what majorly you can say it is removed. So this now non chrome wastewater It might have, okay, so since the pollution will go on, so it will have another impurities as well, which will be further sent to a normal ETP section, where first is primary treatment provided. Okay, so non-chrome wastewater and all the other wastewater streams, they are sent to equalization tank, and then it is provided with the primary clarifier, which further goes to aeration tank and secondary clarifier, and finally the treated water is collected. Now the sludge that is obtained, it will have um, high amounts of chromium still remaining. So it majorly contains chromium in it. So water which is treated, it can be recycled and reused, but the sludge that is obtained, it is chromium rich. So to um, deal with such sludge, it cannot neither be sent to incineration where um, you know uh, it is burned, because it will generate uh, gaseous stream which will be rich in chromium, for example. So in that case, incineration is also not advisable, and agricultural use of such sludge is also not possible because it is toxic, right? So what the last option remains is nothing but sent it to landfill sites. Uh, yeah. So now, if we talk about the air and noise pollution, so all the instruments, there will be, like in any industries, there will be large amount number of pumps used, number of uh, motors used. So all such sort of instruments, they generate a high noise pollution, right? So that was all about how uh, wastewater is generated from tannery industry and how it is treated. And next comes is the petroleum and petrochemical industry. Now, if we talk about petroleum and petrochemical industry, then petroleum industry is nothing but using uh, crude oil. You are generating various petroleum products, which includes uh, petrol. One of the important example is petrol, diesel, then jet oil, jet fuel. Then you generate n number of other products in the form of coke, which is the byproduct. Then you have uh, light vacuum oil, for example. Light vacuum oil, for example. So that is very high carbon chain. So that is further sent to fluidized catalytic cracking, where you provide hydrogen and catalyst, so that it is further converted into gasoline product. So there are number of, so it is a distillation column where uh, different cuts are provided to form various products and byproducts. Now this, if we have something which is very high in carbon chain, so that can further be broken into our useful products, where these are the main products out of uh, the petroleum refinery industry. So there are n number of steps involved, so we will not be discussing deep of it, but there are two main distillation columns which are the heart of any refinery, and further at each and every cut, to have a pure stream and to either enhance the properties or to have some treatment, you provide some reactor or treatment step to each of these steps depending on the requirement. So the heart of refinery is nothing but ADU and BDU. So they are in series. Okay, so ADU is nothing but atmospheric distillation unit, and VDU is nothing but vacuum distillation unit. So ADU is, it works where it is a distillation column where crude oil is separated into uh, various fragments by under atmospheric pressure condition. Okay, but this crude oil has thousands of products in it. Okay, which are fragmented into gasoline, diesel, jet fuel, etc. Right, but at the end of the atmospheric distillation unit, there are still uh, bottom products which are not separated depending on the type of the carbon chain or depending on their boiling points and applications. So their boiling points are so high. So to reduce the amount of heat provided, we provide vacuum, because vacuum, if we provide vacuum, then there is a relation between the existing pressure or surrounding pressure and the boiling points. So if you reduce the pressure, there will be a reduction in the boiling point. And so by providing or vacuum or reducing the pressure inside the column, what doing, you are reducing the boiling points of each of these components in it, and you are able to separate it and recover the products that you require, right? Now if you talk about the crude oil, then crude oil might have impurity in the form of sulfur content, right? So sulfur needs to be removed, because sulfur, if it is present in crude oil, it will end up with any of the products. For example, if petrol is having sulfur content in it, then its properties will be completely different. So sulfur is not at all advisable uh, in any of the products that are obtained. So in that case, what you have is H2S is one of the product, or in case byproduct, and H2S is obtained by the desulfurization of any of the products or the crude oil. Now to remove the H2S, or to not send it to atmosphere, what we do, we send it to strippers, where water or another chemical reagent is provided. So let's say H2S, which is a gas, it goes in the upward direction under gravity. So you provide a solvent which has the tendency to absorb this H2S, and H2S free stream, and this will be H2S rich. So this will be solvent which is uh, not having H2S, and this will be H2S rich solvent, right? So you want to remove H2S, so there will be a solvent which may be used, water may be used. So water may be used to dissolve H2S. So water with high sulfur content might be chances. There are high chances of having water with high sulfur content. Then there are number of organic products which are formed. So uh, you know, each of these steps will generate oily effluents, right? Further, as I mentioned, that there are chances that caustic can also be used to remove H2S, or water can be used. So spent caustic. Further, uh, in the fluidized catalytic cracking, you provide uh, or you use catalyst. Now each of these catalysts that are used, it has some efficiency. So when it is exhausted, so you need to regenerate, and for regeneration there will be some heat provided, some washing provided, right? So regeneration effluents are also a source of wastewater in this plant, and sanitary waste from toilets, right? So to remove oil which is present in wastewater, you can use dissolved air flotation or cloth flotation. Then To remove any sort of suspended solids, you can use clarifiers. And for removing phenol and other organics, uh, so these are the composition of it. Now to remove any organics, you can use anaerobic and aerobic digestion. So the methods are same, but depending on the amount of it present, the dimensions changes, as well as the source might be different. Further, the organic contaminants which are present, it might be different, right? Now the sludge that is obtained, so sludge can be any from any clarifier during wastewater treatment, or also if you talk about the vacuum distillation unit, then there are chances that solids are formed at the end as the end byproduct, okay, which could be coke. So in that case, to separate sludge from water or separate sludge from any liquid stream, you can use thickeners and centrifuge to separate solid and liquid. And the solid, depending on the composition, it can be disposed of in the landfill sites. Now, if we talk about this plant, then it also generates high amount of air pollution, because as we talk about here, there is high sulfur content in the uh, uh, crude oil. So if there is high sulfur content in, during desulfurization of these uh, crude oil and flue gas, H2S which is formed, uh, there are chances that not all H2S is recovered, and during sulfur recovery, H2S it escapes into atmosphere in the form of H2S or SOx. Further, NOx also gets generated. So it is advisable to have an optimum use of air to oxygen or air to fuel ratio in boilers, and yeah, by using low excess air and tall stakes, right? So this is about petroleum industry. Now, one of the product from petroleum industry is nothing but naphtha, and it could be light naphtha depending on the, or heavy naphtha depending on the carbon chain. So these naphtha is converted into various petrochemical products. It could be nylons, nylon 6, nylon 6, uh, styrene, butadiene, and any such sort of polymeric material. Okay, where n number of reactors could be used for polymeric reaction to happen, right? Where some intermediate products are also formed, and then it is converted to final products. So here also, since organics are used as the raw material and organic polymers are formed, so the air pollution could be generated by the spillage uh, from the storage tanks, through leakages, through transmission, right? And wastewater streams can be generated uh, from the reactors, because if you look into, like, this is a very simple process flow diagram where you're just shown what products are formed. If you took see into just one stream, okay, let's say naphtha is converted to olefins and to ethylene, which is converted to PVC, for example. That process also requires n number of reactors and n number of steps. So there are multiple reactors, columns, purification processes, condensers, reformers used, and each of these processes they generate wastewater streams. Okay, and further there could be pipelines, flanges, which might generate leakages, right, through it, and it could be the source of emission. Now, these are direct sources because these are directly related to process. Now, secondary waste emission is nothing but which are used in the industry. Okay, so for example, boilers are used in industry to generate energy or to generate steam, but that uh, boiler is secondary equipment. And it is not the main process in the industry. So all these processes which are uh, sub processes, uh, or if you talk about cooling towers, so it is used in heat exchangers. So the water is used in heat exchangers. So these are indirect sources of waste emission or waste generation, which is nothing but secondary waste emission, right? Now next is the pulp and paper industry. Now, pulp and paper industry is one of the major or highest polluting uh, industry in terms of wastewater pollution. So, let's look into the process flow diagram where how or from where water is generated. So, first is debarking and chipping, where you just because paper is mainly generated from wood source, okay, by converting cellulose into paper, right? So for the cellulose into pulp, and that pulp is converted into paper. So first is debarking and chipping, where you are converting wood into small pieces. Then there could be some mechanical pulping or chemical pulping, but now majorly chemical pulping is provided, where you add some chemical to convert uh, this wood into a slurry pulp sort of thing, right? And it is further used to remove the lignin which is present in the wood. But the lignin is very difficult to remove. So after this step also, the pulp which is formed, it has high impurities, and it has high amounts of lignin, and
Hello,
which
ma'am.
is dark brown in color. So in that
Hello,
case, to
ma'am.
remove the color, yes.
Oh, sorry. Actually, there was some network issue, but I wanted to ask, what are plasticizers? In previous slide, it was mentioned. In the flow sheet, it is just above ABS, plastic, PBR, and SBR. Is mentioned plasticizers. What are plasticizers?
Uh, just minute. It These are nothing but the polymers that enhances the elastic properties or plus it it facilitates the the property of plasticity or fluidity of the material, and depending on the application it will uh, you know
They help in molding the material. Is it that so? Making it more flexible to mold.
yeah, you can say that.
Okay, okay. Thank you, ma'am.
Okay. uh, okay, so just a second. Yeah, so now the pulp is still there will be lignin which is present, and the color of lignin, if you see, it is dark brown. So to remove any sort of color which is present in pulp and the minor lignin content, you provide bleaching, okay? And by providing bleaching, you see the completely dark brown pulp. It is converted to white um, color pulp. Now this pulp is then sent to, like, this is the final pulp which is sent for blending, and then finally any sort of additives and uh, um, for example adhesives, dyes, and some property enhancers, they are added and they are converted into uh, rolls, okay, by spreading and removing the water content which is present, okay. So the main source of wastewater in this process is nothing but bleaching, and it is highly high content of lignin is there. Now this lignin is also, you say it is um, very difficult to degrade. So in that case, what you do, you provide anaerobic digestion instead of a direct aerobic digestion to that wastewater, so that in the absence of oxygen, the degradation happens to generate biogas and methane, and later you provide aerobic digestion, and whatever the sludge is obtained, you can send it to landfill sites. Next method could be the fertilizer industry, where your major industry in fertilizer making is urea industry, where urea is the source of the nitrogen which is required as the important nutrient for um, um, the plants to grow. So this is the urea plant where or the synthesis process, where the urea is having this formula NH2CONH2. So it is formed by using ammonia and or the reaction between ammonia and CO2, where this is the uh, intermediate which is known as carbamide. Now, and here, so first ammonia and CO2, they are sent to reactor, and intermediate product is formed, and finally, like the series of reaction happens, and whatever, like, not in industries, no reaction goes to complete conversion, okay. So there will be ammonia and CO2 remaining. So in that case, it will be advisable to recover the ammonia because it is easier, it has it is in gaseous form, so it is easier to recover. So you recover the ammonia, and further whatever the urea is formed, you send it to, like, it is peeling tower are nothing but for generating solid urea by spraying it in the form of powder, I guess, like uh, yeah, and later it is uh, sent to storage and storage tanks, and from that it is converted into final, like, it is packed in bags and sent it to market. So here, during entire process, you see one of the major byproduct is water. So sources of wastewater will be the process wastewater, the condensate which is used, condensate which is formed, and scrubber is also used during the stripping process. So scrubber, the waste which is generated from scrubbers, and heat exchangers are also used, which generates cooling tower blow down wastewater, right. And the major content of these wastewater would be organic compounds, because of any side reaction that would be happening, because uh, if you look into the industry, then the reactions are very complex, and you cannot say that only single product is formed during the process. There could be multiple processes or reactions taking place, which might generate some other organic compounds, nitrates and alcohols, right? And ammonia um, could not be removed totally or recovered totally, which might end up into wastewater, right? So now, if we talk about air pollution, so it could be because of uh, during the processes like blending, uh, while storing. Okay, some might escape along with the air and bagging, right? And the wastewater could be high in nitrogen content. So where you can use biological treatment for nitrification, denitrification, and you can convert it into N2, or you can also use ion exchange to remove nitrogen content, because otherwise it will cause eutrophication in further steps. Last is the copper smelting process, where copper is nothing but generated from the ores. It could be sulfide or ores or oxide ore, and depending on the type of ores, the process will be different, right? So here, a major source of the ore is involved. So you might have crushing of ores, and lot of drilling and mining will be required, which generates a lot of particulate matter and dust, along with other heavy metals, SOx and NOx. So these are the major air pollutants. And if you talk about water pollutants, then there could be some soluble and non-soluble metals, because um, copper is synthesized. So to synthesize copper, there could be some other heavy metals also present, and also copper will be obtained as impurity in the wastewater, which will go. So soluble and non-soluble metal compounds, organics, and acidic nature of wastewater is um, formed. Now, if you talk about this industry, then mining is, there are, it generates a lot of noise, because if you have uh, seen any, like you are digging deep into the earth, you are breaking the soil, you are going deep, you are crushing the top layer of the earth to go deeper into the mine, to do mining where ore is present. So that sort of drilling, and it generates a lot of noise. So it is advisable whosoever is uh, goes into this industry, they should take proper care by using earplugs and so on. And this industry should be far away from residential area, right, or any uh, commercial area as well. Now let's start with the assignment. So the first question here is, mm, which of the following feedstock contributes to the largest production of ethanol globally? So we are not asked about Indian market. So we are asked about uh, in global scale. So can you say which is the largest feedstock used? Um, so the topmost contributor to this is nothing but coarse grain. Okay, so grains are used for the generation of ethanol. Next is the percentage composition of fermentable sugar in molasses is dash. Okay, so molasses is a byproduct from sugar industry, which contains the sugar which is not extracted during the process. So that molasses still contains 40 to 45% of sugar content, which is later converted through fermentation process into ethanol. Next is dilute molasses media present in the yeast vessel is heated at a temperature of dash. Oh, okay. So here that heating temperature is nothing but 80 to 85 to 90 degrees Celsius. Next is favorable condition for Maillard reaction is dash. Now we have seen during ethanol synthesis that there could be some side reactions also taking place depending on the existing or prevailing conditions of a reaction or conditions maintained. So, if the conditions maintained, like for yeast to have favorable fermentation reaction to occur, 37 around 35 degree to 37 degrees advised, or it is advisable. However, if temperature is maintained above 50 degree and pH to 4 to 7, then in that case, Maillard reaction it progresses. Next question is tanning is a process of treating animals' skins and hides to produce. It is a very simple question to produce leather, right? Next is sludge generated during tannery process is generally managed by dash. Now, produced from tannery process is rich in chromium, which is highly toxic. So, in that case, what you do, you need to dispose it into landfill sites because of its toxicity. It cannot be open disposed in open land also because it some uh, other secondary pollution can happen. And also during incineration, there are chances that air pollution will increase. So landfill is the best option for this. Now, which of the following is not produced during the processing of crude oil? Now, crude oil is majorly converted into organic compounds, including LPG, biodiesel, jet fuel. Now, if you see bio oil, then it is the process which is, or it is the fuel which is generated through some organic or some fermentation process. So, that is not the correct answer. So, it is not formed from the crude oil. So, bio oil is the correct answer in this question. Next is wastewaters generated from chemical fertilizer industry mainly contains dash. So if you look into the options, then alcohols, yeah, it is present by conversion. Okay. The next option is ammonia. So ammonia will also be present because ammonia is the major reagent used. So during recovery step, some of the ammoniumide which is not recovered, it can end up into wastewater. And obviously heavy metals, right? So all of the above is the correct answer. Now wastewater generated from copper smelter contains dash. So it contains since ore is mining is done from the ore, so it contains soluble metal and non-metal metal in the form of soluble and non-soluble compounds. So both A and B, along with some oils, okay, uh, might be present. Uh, for example, if grease are used or some, yeah, so if you are using grease, then it is also a kind of oil which can uh, uh, end up into wastewater if water comes into contact with grease. So that is also one source of oil in wastewater. So all of the above is the correct answer. Next is this is the last question, which is a numerical. So in an industrial biogas plant, uh, food waste is anaerobically digested to produce biogas, and the slurry contains 10% of solid food grains. Now, the elemental composition of food grains on a dry basis is C 50%, hydrogen 5%, oxygen 35, nitrogen 10%. On mass basis, now around 95% of food grains are converted to biogas, and all the converted hydrogen forms methane. Now, if the flow rate of slurry is 3,500 liters per day, calculate the rate of biogas production. So rate of biogas production is nothing but you need to find out biogas formed in 1 day. Okay, so what is the, sorry, the amount of slurry which is going in or which is going inside the biogas plant, which is 3,500 liters in 1 day. So let's take the basis of 3,500 liters. So whatever we will be getting, it will be per day. So now 3,500 liters of slurry contains 10% solid, right? Solid food. Now this 10% of 3,500 is nothing but food is equals to zero point 0.1 into 3,500, which is equals to 350 liters. Now here there is no basis given, so assume the density to be 1 kg per liter for slurry. So for 350 liters of food, the amount in the terms of kg, it will be 350 kg food. It is going inside the biogas plant per day. Now this food has 50% carbon. So carbon is zero point 0.5 times 350, which is if you do 0.5 into 350, it will be 175. So 175 kg carbon. Hydrogen is 5%. So 0.05 times 350, which is 17.5 kg. So majorly you are concerned with both these. So let's not go into this. Now biogas is formed by converting C plus O2 to give CO2 and C plus 4H to give CH4. Now here another hint is given that there are 90% conversion to biogas and complete hydrogen is completely formed into methane. So okay, all the hydrogen is used up to form methane, right? Now biogas could comprise of both carbon dioxide and methane. So to form the basis, we can say that entirely 17.5 kg because carbon can be used in both the reactions, while hydrogen is only used in this second reaction. So you can say that completely 17.5 kg is used up to form methane, right? So if you look into the stoichiometry, then 12 gram requires 4 gram of hydrogen to form 16 grams of methane. So if we have 17.5 grams of hydrogen, then what would be the amount of methane formed? So that will be nothing but 16 cross 17.5 divided by 4. So that is nothing but, sorry, 17.5 cross zero point 0.9 because 90% conversion is there, and with this 90% conversion, whatever will be the hydrogen used, that will synthesize methane. So into 0.9 it will be 63 kgs of methane formed. So methane formed is 63 kgs. Now, what will be the carbon usage? Carbon usage for methane production for CH4 is nothing but 4 into, sorry, 12 into 17.5 into zero point 0.9 divided by 12. Okay, you are just cross multiplying this. So it will be 15.75 kg carbon used for methane production. Now, rest carbon which is utilized, it will be converted to carbon dioxide. So again the 90% conversion is given, which is for applicable for both carbon and hydrogen. So 90% of this 175 is the conversion of carbon. Okay, so conversion of carbon to biogas is zero point 0.9 cross 175, which is 157.5. Okay, so now out of this 175, 15.75 is used up for methane production. So whatever will be the remaining one, 157.5 minus 15.75, that will be used up for carbon dioxide production. Okay, so 157.75, yeah, zero point 0.5 minus 15.75 is 141.75. It will be used for CO2 production. Now, if I write the reaction, C plus O2 gives CO2. So carbon with 12, this is 44. Okay. So what will be with 141.75? So let's cross multiply this. So 141.75 into 44 divided by 12. I have made a calculation mistake. Wait a minute. Okay, sorry. Here it is not 15.75, it is 47.25 kg of carbon used for methane production. So if you subtract this, it will not be this 141.75, it will be 157.5 minus 47.25, which will be 110.25 into 44 divided by 12. So that is 404.25 kgs of carbon dioxide formed. So total biomass is nothing but addition of carbon dioxide formed and the methane formed. So plus 404.25 plus 63 is nothing but 467.25. So C is the correct answer. Yeah. So do you have any doubt? Okay, so if not, I will end this meeting here. Thank you everyone for joining. Thank you.